Approach, 10 glitch link, 11 GitHub. Social VR for the Metaverse with A-frame WebXR, 1 book credits, for book corrections, 4. Introduction, 5 What is WebVR, 5 What is WebXR, 5. Why do VR inside a browser, 6. What is A-frame, 6 How to begin, 7 The technology stack visualized, 7 The tick and rendering. Loop, 8 Note to developers, or the browser cache can be a pain, 8 Future tech, 9 The book. Approach, 10. Glitch link, 11. GitHub link, 11 rocketvirtual.com code example links, 11 Chapter 1, Hello World VR. 13 Geometric shapes, position, rotation and color, 14 Using the A-frame inspector, 16 Changing colors, 18 Creating a custom sky. 20. More geometric primitives, 22. Versions, documentation, bug issues and inspect console, 23 Chapter 2 E-animation, lights and shadows, 28 Mix-ins and animation, 28 Lights and the shadow. Camera, 29 Chapter 3, VR environment, movement and selection, 32 Creating a VR environment, 32 Movement while inside VR, 34. Loading and displaying 3D GLTF models, 37. Selection with Raycaster, 38 Controlling audio, 41 Dramatic effects, moving the camera, 41 Dramatic effects, toggling the environment. 42 Chapter 4, Inside the sphere, 43 Painting the sphere, 44 Problems with this photo, 45. Teleporting through multiple 360-degree scenes, 47. Solving the large 360 degrees video file problem, 49 Hosting 360 degrees video on YouTube, 50 Chapter 5, Social VR, 51 Networked A-frame. NAF, 55 Your own VR server, and why, 56 If you want to set up your own server, what does that entail technically? What is the cost, 56. 2. WebRTC, 58 Adapters for network to frame, 58 My disclaimer, 61 Some assumptions, 61 Purchasing and setting up a domain name, 69 Configuring Apache with your domain name and virtual hosts, 70 Setting up networked A-frame. NAF, 75. Testing NAF, 80. SFTP, 83 Chapter 6 is some social VR spaces, 84 Hexoplex Garden, 88. Avatars, 88 Art Room Gallery, 98 Sci-Fi Themed Island, 99. My VR History, 99. Other avatar systems, 100 Personalized avatars, 101 Video avatars, 102 Gifting 3D printable assets, 104 Chapter 7 Bringing it all together, 105 Treasure Island Art Gallery, 108. 3 Road Party examples, 109. VR launch pages, 110 Inside VR screenshots of final examples, 111 Addendum, optional, 121 Installing Drupal. 9, 121. 3. Book credits. It takes a community, especially for all the things learned over the years about virtual reality inside of browsers over the internet, leading up to and during the writing of this work. I would be remiss if I didn't mention the individuals who helped me out along the way, in one way or another. Whether it was through support on Discord, Slack, GitHub, Stack Overflow, Glitch, Twitter, Medium, YouTube, open source code, documentation, and examples, a video call, an in-person meeting, or just simply an encouraging email. Bravo to all, I am in your debt, Diego Marcos, Supermedium, and A-Frame, support on Discord and emails, Vincent Fretin, Network to Frame, Ada Rose Cannon, W3C WebXR GitHub XR boilerplate example, Twitter text, Simple Navmesh, Kevin NGO, A-Frame, GitHub, Meetups 2016 to 2017, Don McCurdy, A-Frame, Navmesh, GitHub, email, and Kieran Farr, GitHub examples, discussion of book approach, and subject matter, Diarmid McKenzie, GitHub examples, and Brandon Jones, early WebVR examples, Meetups 2016 to 2017, also for your technical discussion, and greatly appreciated code testing assistance, experimentation, and support, my good friends Sean Sweet and Frank Weiss. Thank you all very, very much. Book corrections. Before I finally begin, it is too optimistic to think that I can write a perfect book the first time. I'm only human, and make mistakes just like everyone else. So with that in mind, some things can be corrected or improved after the book is completed and published. I'm including a link to a corrections page below. I will endeavor to keep it updated. No corrections yet. https://funbit64.com/drupal/index.php/node/10 https://funbit64.com/drupal/index.php/node/104 Introduction. A-Frame HTML open in browser inspect console tab in Firefox. Although virtual reality (VR) as a technology has been around for some time, it is only recently that consumer hardware, more commonly VR headsets, have become available at an affordable price. At the same time, open-source repositories providing for the easy coding of VR with HTML and JavaScript inside a browser are now available for free download. The browser is undeniably the killer app of the Internet. What is WebVR? Historically, there was a technology called WebVR, which is a JavaScript API for creating immersive 3D virtual reality experiences in your browser. WebVR has since been deprecated, meaning it is now superseded by WebXR. This can be somewhat confusing because there are still many older examples of WebVR on the Internet. What is WebXR? WebXR is the new W3C specification for browsers. In addition to virtual reality, it includes technology specs for augmented reality, AR. Hence the X in WebXR can be variably a V or an A representing VR or AR respectively, or sometimes referred to as mixed-reality. XR is officially referred to as extended reality. There is a spectrum of virtuality called the virtuality continuum in computer science. Use this link to determine which browsers support the WebXR API. This book will focus on virtual reality and will explore coding inside a browser, taking into consideration the basics and some new developments. We will assume you know HTML and some light JavaScript as a prerequisite. If you don't, there are many free articles and videos to learn from on the internet. Just search for them, study up, and come back here. 5. Why do VR inside a browser? Well, many web developers already create websites for the internet, and know and use HTML and JavaScript daily. Also, most every device these days, smartphones, computers, tablets, comes with a browser installed, or it can usually be downloaded free. Plus, the software tools for browser development and 3D modeling are diverse, powerful, and with many of them, again, absolutely free. Example: Blender. Finally, given the ease with which you can deliver an immersive VR experience to someone, by simply sharing a URL address with a friend or social media, doing VR inside a browser just makes good sense. It's also possible WebXR is the breakthrough spec upon which a large part of the future hypothetical Metaverse may be built. Hello World example with A-frame inspector open. What is A-frame? First, recent versions of A-frame are WebXR compatible. A-frame is an open-source web framework for building virtual and augmented reality experiences. It is a framework based off an entity component design pattern which leverages the power of Three.js, sometimes capitalized in code or literature, for the easy creation of 3D immersive experiences, simulations, scenes, and games. 6. How to begin. If you are just starting out with A-frame, you should probably first learn the basics for creating primitive objects, positioning them, their rotation, visibility, transparency, controlling lights and shadows, simple animation, manipulating your environment, loading assets and 3D GLTF models, controlling audio, and implementing selection in movement while immersed inside your VR app. Be assured, we will go through all of this to some detail inside of this book. The technology stack visualized. For those interested in a high-level view of the overall technology stack used, the figure above can be helpful. 7. Since A-frame wraps an instance of Three.js and follows the WebXR specification, it allows for VR and AR inside a headset device browser. As an example, the Meta Quest 2 browser, which I understand is based off of Chromium Blink. VR AR can be accessed from a variety of vendor headset hardware devices, browsers, and shared across the internet by a simple URL address. The only downside being the time it takes to download heavy graphic assets into a browser. But remember, when you install a game or other app the first time, you are incurring an install download time. We just tend to forget about it. However, after the browser has cached the assets, they will usually load much more quickly the next time the page is loaded. Some of this will be mitigated in the future. Internet access speeds are always increasing, for example 5G, as well as more powerful mobile graphic processors, and with enhanced resolutions and eDGE computing AI capabilities. A tetherless VR headset has basically all the hardware components of a smartphone, plus optics, controllers, all in a head-mounting case. The tick and rendering loop. There is such a thing called a tick, or a frame of the scene's render loop, meaning the scene is drawn before it's pushed into the VR headset on each frame, or tick, of a rendering loop. This usually happens many times per second. It gives an appearance of smooth animation of objects, while not causing nausea to the VR headset wearer. This rendering loop is found inside of all game engines. You can find out more about A-frame tick and its rendering loop here. Note to developers, or the browser cache can be a pain. Caching and sessions can be complex to understand. I recommend changing the name of your HTML file name while testing and debugging changes in the code. This will usually resolve any confusion as to whether you're testing an older cached version or the actual code change you just made. This won't be a problem with our glitch examples, discussed further on. This advice is mostly for when you are using your own web server development environment. I self-host, usually on a VPS, but there are many cloud options. Ultimately, if you are unsure, try it in a different browser, such as Firefox, or Edge that you haven't used with that file name before. Clear all the cache, and when you are done debugging, change the file name back to the desired file name. It works for me. Finally, I might be stepping out on a shaky computer science limb here by saying, A-frame programming of WebXR with its entity component system and attributes might be considered attribute programming, or declarative programming, but when you add JavaScript it becomes imperative programming. So, I don't really know, call it what you want, it's programming VR in a browser to me. 8. Future tech. Given some time, probably in the mid to late 2020s, I truly believe VR headsets and AR ones will merge and become as indispensable as the mouse is for 2D screens. No more sticking smartphones into cardboard, that time will have long come and gone. Also, think no need for controllers in the future, hand tracking, just VR hand gestures for manipulating and interacting, as well as emerging eye tracking hardware. So the future is bright. Let's start learning and building it today. 9. The book approach. The easiest way that I know how to teach VR in the browser is with lots of example code, slowly starting from the basics to increasingly more complex. That's how the next chapters will be taught. We will start with the original A-frame Hello World and progress to our more advanced example Hello World VR. Along the way, I'll refer to each example and point out specific details along the way. You will be allowed to modify the examples yourself and experiment with things as we go. In fact, I encourage it. The best way to learn is by trying, and the best teacher is making mistakes along the way, and then learning what is necessary to correct them. Of course, avoiding them is most desirable, but not always possible. We live in an imperfect world, and I wouldn't have it any other way. Which in actuality makes it perfect. Pardon, that I got a little philosophical there. 10. How the last example code in Chapter 3 will look when loaded into Glitch with Preview on right. The documented code will be presented in Glitch, which allows for easy remixing and modification. Refer to Glitch documentation on how to use. I also provide the code on GitHub, with links to the working examples. I have made every effort to make sure the source code and its assets are original or open source, with no copyright infringement. If this is found to not be the case, I sincerely apologize, because I wish to respect the rights of all creators and their original work, as you should always do. Glitch link. https://glitch.com/edit/$!! handy-enormous-nightshade. https://glitch.com/edit/$! handy-enormous-nightshade GitHub link. https://github.com/mike-McAnally/VRBook Rocket Virtual.com code example links. https://github.com/mike-McAnally/VRBook. Chapter 1, Hello World VR. Let's start with the basics for A-frame Hello World. 13. Geometric shapes, position, rotation, and color. Look at the source code helloworld.html and its browser rendition, HTML displayed in the browser. It's HTML with comments. Things are indented with extra lines for readability. Now notice EA scene, line 18, its entities, A box, A sphere, A cylinder, lines 22 to 24, A plane, line 27, A sky, line 30, and a closing EA scene, line 31. Also notice EA box has a closing EA box, as do the other shapes. The attributes within EA box are position, rotation, and color. The position of the box is defined as x, y, z coordinates separated by a space between quotes. Position is defined as in a Cartesian coordinate system, where the z-axis is a positive value coming outward from a 2D screen and negative value going backward into the screen. If you imagine we are standing at the origin of 0, 0, 0. With A-frame by default, we are actually looking at things with our virtual eyes from a height of standing 1.6 meters tall. So that would mean our viewpoint is really at position 0, 1.6, 0 for our x, y, and z axis values in this first scene. A scene being the virtually defined area created by A-frame, sort of like a 3D 360-degree play stage. Because our UA box has position equals 1 0.5 minus 3 means it appears minus 1 to the left, raised 0.5 up and minus 3 back into the screen, if that makes sense. The same goes for the other geometry shapes in our scene, which all have their own positions defined. With our EA box rotated at 45 degrees counterclockwise on the y-axis, giving it an angle on our 2D screen, and the appearance of depth. 14. If you drag with a mouse or touchpad in the center of the screen, you can rotate our view of things much like turning our virtual head. If you press the W, A, S, and D keys on the keyboard, you can move, step, forward, left, right, and back inside the scene. Amazing, right? 15. Using the A-frame inspector. A-frame provides for a way to change the attribute values in a scene dynamically inside the inspector. You'll then have to copy those changed values back into the source code and save them, for them to take effect. To enter the inspector, press the Ctrl-Alt and I keys simultaneously, Ctrl plus or Alt plus I. In the left panel of the inspector you will find your EA scene, and all objects including ebook. Select ebook and notice a right panel appears with the attributes for the box, along with positional arrows, red, green, blue. These allow you to move the position of the box while affecting the position values in the right panel. Try it. Notice the controls on the top, just slightly left of the right panel. Select the rotation circle control, like this. 16. You will now notice a change to the EA box. Now select holding down while dragging on the green circular line. Notice when dragging left or right. The box, or cube, rotates. Also, the rotational values for Y in the right panel update as well. Correspondingly. 17. Changing colors. Now scroll down on the right panel to the section under Material called Color. Select the blue rectangle. A color picker will appear allowing you to change the color of the cube. It also displays a hex value hash for CC3D9 next to the colored rectangle. This is the value of the color attribute on ebook in the source code. By changing that value in the source with an editor of your choice and saving it away, you will change the color as well when the HTML loads in the browser, the next time you refresh the page. In Glitch, things are saved for you when you remix and modify the code. 18. A multitude of color to choose from, so let's do that now as an exercise. Change the color of each of the geometric shapes, a box, a cylinder, a sphere, and save away our source code and refresh the browser. There are a number of color picking sites on the internet which you can use to generate attractive color palettes to use in your A-frame scenes. Copying the hex values into your source. Color generator link https://coolers.co https://coolers.co. The results will be something like this, depending on the colors you choose. 19. Creating a custom sky. Now we are ready to move on to our next exercise. Take a look at the new source code Hello World 2.html and browser rendition. 20. Notice the EA Assets tag contained within the EA Scene tag. We have an img tag on line 21 which is given a source src of landsky.jpg stored in an assets img directory. We have assigned an ID equal to the name or label of texture1. Much further down on line 34, we have the EA Sky tag, which we have given a material of source #texture1. This assigns the landsky.jpg file as a texture material for the sky. So imagine the sky as a gigantic sphere of which we are inside of, and inside the center of the sphere is painted with the texture of landsky.jpg. That is essentially what is happening here. The actual landsky.jpg file looks like the image above and the eSky tag wraps it around us. 21. You can see this if you enter the A-frame inspector again, Ctrl+Alt+I, then select A Sky in the left panel. Now scroll back away from the screen, keep scrolling a lot, until a sphere will appear with the landsky.jpg texture mapped onto it. You should imagine yourself as inside this painted sphere when you are in true VR. Now scroll back into the normal size view inside the inspector. More geometric primitives. We are going to modify the code and add more geometric primitives, maybe even some you have never heard of. I hadn't. First, let's modify our box, sphere, and cylinder by using the EA-entity tag with the geometry attribute. This is a more general way to create geometric shapes. Notice we are using primitive box within the geometry attribute. Now let's add a new geometric primitive, dodecahedron, with 12 faces or sides, to the scene, giving it a radius, position and rotation. 22. Our modified scene should look something like this. In Glitch, this is the hello world for .html. Versions, documentation, bug issues, and inspect console. Up until this point, we haven't talked about the A-frame JavaScript framework, which we included near the top of the HTML. First, notice the version number 1.3.0, which is important, because A-frame tends to change rapidly and sometimes things can get broken or become buggy along the way. Meaning A-frame is under rapid development, and because of that some things don't work in newer versions of A-frame. This can even be sometimes because of changes to the browser itself. Not to worry, A-frame seems to be increasing in code stability as version numbers increase, as this is a natural result of any software development. 23. Issues with latest A-frame master and releases can be found under the Issues tab on GitHub. A-frame can be found on GitHub here. The website for A-frame can be found here. The detailed documentation for A-frame can be found here. Something else which will be useful for you is the ability to inspect execution of your code while in the browser. You probably won't have to go into the length of how to debug JavaScript in our exercises, just know how to access the console first, which can be really useful. I use a right-click in the center of the screen, select the Inspect option, then select the Console tab. 24. Console tab in Chrome inspect showing version of A-frame with any possible warnings, errors, and info. Now with all that said, we are going to add many more geometric objects, but first we are going to add a new A-frame compatible JavaScript component to our HTML to help us with laying out the positions of all those new objects we will create. 25. The A-frame layout component is very useful and can save a lot of time and effort. We added it right after A-frame itself in the code above. See Hello World 6.html. We are now going to lay out our new geometric shapes in a circle around the existing shapes of box, cylinder, and sphere. We do that with an EA entity and layout attribute with a radius on the XZ plane. We position the circle and include all our new shapes inside the closing EA entity block, which affects all the shapes within, assigning each of them relative positions equidistant from each other. So we don't have to actually assign a position attribute to each shape. That's great because layout nicely takes care of that for us. We are also going to add one more sub-attribute to material called opacity. Opacity allows us to make things partially transparent like glass. A value of 1 is no transparency, which is the default. A value of 0.5 is half transparent, and so forth fractionally. 26. Our scene should now look like this. 27. Chapter 2: E-Animation, Lights and Shadows. Mixins and animation. Now we are going to add something called mixin. It is tagged as EA Mixin and goes in the EA Assets block. It's sort of a shorthand variable attribute for use throughout the EA Scene section. Inside our mixin, we are going to do some animation for the first time. Animation is done in a frame with the animation attribute, and in this case can do a looping rotation on objects that are assigned the mixin. Here is the code in Glitch for Hello World 7.html and the browser rendition of that code. 28. We added 3 mixins with the IDs of spin Y, spin X, spin Z. Each one of them spins around a different axis in the Cartesian coordinate system. You can see that in the parameters within the animation attribute rotation, to 0360 loop, true means spin continuously around the y-axis, for example. The others have 360 on each other axis. The mixin IDs are then used with the mixin equals attribute and assigned to each object entity. For example, the cone is assigned the spin X mixin, which will make the cone spin around the x-axis. Mixins are very powerful shortcuts in a frame and used to shorten effort and the readability of code. Lights and the shadow camera. Let's first extend our plane a little larger so we will be able to see all the shadows the light will cast by extending its width and height to the value of 12. Then we are going to create something that is a light with a shadow camera. Inside our new entity, we create a light with cast shadow, true. That light also has attributes for a shadow camera. There are a number of parameters for the shadow camera which control the size of where the shadows will fall when the light casts upon them. 29. The shadow camera light is a fairly complex entity and we give an example of it here. However, we are not going to go into too much detail. You can find more in the A-frame documentation. One thing to point out is that the shadow camera must be adjusted correctly for the shadows to appear correct. With our light and shadow camera added, our scene object shadows have darkened a little bit. To fix that, we will add an ambient light to brighten things up, setting its intensity to 0.7. Also, we are going to add additional shadow and render control attributes to our EA scene. This will soften the shadows, reduce their graphic processing load on the GPU, and improve aliasing and increase refresh rate of the VR display. In Glitch Hello World 9.html. 30. This is how it should look with the new objects animating around the original box, cylinder, and sphere. We changed the opacity back to 1, or you can remove it entirely, since 1 is the default. We can even animate the opacity, but that is outside the scope of this tutorial. Now, for fun and a more dramatic effect, add the spin Y mixin to the layout circle. It causes the whole layout of the objects in the circle to spin around. That is powerful animation. For a final animation example, we are going to add the animation attribute directly to the layout. This will move the spinning layout circle up and down and reverse its direction. Finally, in Glitch Hello World 11.html and rendered in the browser like this. 31. Chapter 3: VR Environment, Movement and Selection. In this chapter we are going to be focusing mostly on things inside of VR. Creating a VR environment. Our original land-sky environment was simple and effective. However, persons inside of VR are known to explore more extensively, much as they do in the real world, and usually require a richer, more immersive environment. To accomplish this with the least amount of effort, we will introduce and use the A-frame environment component. First, we add our new component in the E-head of the HTML just following the A-frame layout component we added earlier. Then near the bottom of the code just above EA scene, we add the entity with attributes for our new environment, calling it Parkland. Notice we also commented out the ambient light above the plane and removed the sky and its texture from assets. This is because the environment controls some of the lighting and sky itself, all automatically for us, as well as creates a ground for us and adds some 3D models into the scene to make it all that more believable. Admittedly, we don't get the clouds in the sky, but that's a small price to pay for what we do get in return. 32. So let's see. In glitch-hello-env.html and in the browser. If you examine this all in the A-frame inspector, Ctrl+Alt+I, you can see these elements, even play with modifying them. Select Parkland in the left panel, and if you look closely at the right panel, you will see attributes for environment. Also, you will see other entities within the Parkland block, such as lights, ground, dressings, and sky. Explore further. 33. Any changes you make will need to be copied back to the source for them to become permanent. You can copy those attributes back by selecting one of the copy symbols in the right panel, then pasting the text into the source. Let's make another environment, an Arizona desert-like one, by selecting the Yavapai preset and adding that to our code. We will also comment out the other Parkland preset temporarily. The result will look like this. In glitch-hello-env2.html and in the browser. Movement while inside VR. We will be adding a new A-frame compatible component called A-frame Extras for moving around inside of the VR environment, while immersed with our headset on. Note, at the time of this writing, A-frame Extras has picked up a few minor bugs, but they won't affect us directly here in our code examples. So we will still use the powerful moment control add-on provided. For your information, the bugs are related to the ocean and nav mesh. To get these to work, you may need to use earlier versions of A-frame, such as 1.1.0. Which is really fine if you don't need any newer features of A-frame added since, and if you can reconcile any version dependencies between components. Recent update, in a later chapter 1, found a fix for the ocean starting line. 34. 103 in the JavaScript and line 292 in HTML, and later again a substitution for navmesh called simple navmesh in this example on GitHub. Just giving you a teaser glimpse into future chapters. In glitch-hello-move.html and in the browser. Explaining the code, you will see the new A-frame extras.minute.js has been added to the top, right after the other A-frame components we added earlier. Further down, you will see an E-entity with an ID of camera rig with movement controls. It is the movement controls which allow us to move around inside of VR with usually a toggle stick on our controllers. Within that entity you will find another which is actually the camera. We have given it an ID of head instead, because it represents where our eyes and head would be from the camera's perspective. 35. Inside of the camera head entity you will find two other entities which represent the left and right hands of our virtualized hands, or partial avatar, inside of VR. These hands are presented in VR by left and right low poly 3D models that are colored the hex color of blue. Our virtual hands are seen inside of a VR headset. Here is what they should look like inside your VR headset. 36. Loading and displaying 3D GLTF models. Next, we are going to load a couple of 3D models and put them in the environment for both the Desertland and Parkland environments. For the Desertland, we are going to add some cactus, and for the Parkland, we are going to add some trees. The models will be in a format called GLTF, which is sort of a JPEG compression format, but instead for 3D models. We will load those models first inside our assets tag and then display them with an entity later in the HTML code. In Glitch Hello Move 5.html and in the browser. Notice inside the Cactus 1 ID we are using GLTF model to display the asset we loaded earlier #cactus short. We give it a position and a scale which is used to transform its size and shape in the 3 axes. We can make sure it doesn't receive any shadows to simplify any rendering load on the GPU, since it is not needed in this case. 37. We now comment out the Desertland environment and do the same again, but adding trees for Parkland instead. After adjusting some colors in the Parkland scene to make the greens more vibrant, we get this selection with Raycaster. Now that we have 2 scenes set up, we might want to do something that will allow us in VR to have an effect upon them. This will be a bit more programmatically complex, and involves some simple 38. JavaScript. This will result in making the whole scene more functionally interactive. For this example, we will use Glitch Hello Sale 3.html and in the browser. Remember we talked about the hands that you see while inside your VR headset? Well, one of those hands, the right one in this case, will have a pointer laser coming out of it associated with a Raycaster. On the EA scene tag you can see the Raycaster defined in a more fine-grained way. It basically shows the IDs of the objects the Raycaster can be intersected and selected with a period in front of them. It also references a class called Clickable. You can see that our entity objects have class Clickable and an onClick foo function call to JavaScript function while passing in a label variable for the object name. Let's take the example of the tetrahedron. When the Raycaster intersects the tetrahedron while inside the VR headset and the trigger button is pulled, a selection occurs. This calls the disappear function with the object name. 39. Our JavaScript is added. The disappear object name JavaScript function uses the DOM document.getElementById to find the line of HTML, and then set an attribute called visible to the value of false. The attribute visible is not shown in the line, but it's implied and the default is true, meaning the object can be seen. By setting it to false we actually make its visibility disappear. The object is still there, but it has superpowers, and thus is invisible. 40. We also added something called sparkle.play. This plays a disappear sound we loaded globally at the top as a new audio variable called sparkle. For making all the objects visible again, whether any of them were previously selected or not, we use an on-click function called reappear, attaching it to our cylinder. We then play the same sparkle sound for our reappearing objects. You may have noticed a couple of a frame.register component in the JavaScript. A frame has a way of creating custom components. There are advantages to doing this, mostly performance, and more direct access to the control of 3.js. You can find out more about this in the A-frame documentation, where it is explained in detail with examples. Controlling audio. We are going to add a texture to the EA box, or cube, and use it to initiate playing music. We use the material with src as we did with the landsky.jpg texture in Chapter 1. Also notice we added something called Audio Handler, which is an a-frame.register component which handles selecting, playing, and stopping our music. Our music src to play is defined inside our raw audio tag near the top eBody tag in the HTML. It is set to autoplay and loop. Unfortunately, in our case, browsers require the user click to enable interaction, then at least once more to initiate audio. So sometimes it may take 2 clicks to play the music the first time, and then 1 each thereafter to stop and start playing again. Dramatic effects, moving the camera. Now for fun, we are going to add a dramatic effect by including an animation on the camera, or our head ID label, which starts our page far out and then moves it inward towards our objects. In Glitch Hello VR Final 3.html and in Browser, which is the final example for this chapter. As shown, the animation starts at from position 0, 10, 50 and moves in towards to position 0, 1.6, 0, the default starting position in a frame. 41. Dramatic effects, toggling the environment. Another dramatic effect can be achieved by toggling between the desertland and parkland environments. The code above gives an example of this, and the chgenv JavaScript function is activated by an onclick when the sphere is selected. Toggling the active and visible attributes for the environment as well as the objects we put in them. 42. Chapter 4, Inside the Sphere. 360 degrees camera acquire rectangular image of me on a San Francisco beach. Notice the shadow of the tripod's legs are bent. Up to this point our VR experiences have been a little cartoonish. Just meaning they don't seem as real as the actual world outside our headsets. We are going to change that in this chapter. Using 360 degrees cameras is a way to capture the real world and experience it in VR immersively. We're going to use images from my 360 degrees camera to do this in our examples. We are also going to use the same trick we used in Chapter 1, when we painted the inside of a sphere with the landsky.jpg file. However, instead we are going to use images captured and processed from a 360 degrees camera. The difference in these images from regular photos is that they are equirectangular images. Imaging peeling the skin off an orange and then pressing it down flat on a surface. If it didn't tear but stretched instead, it might look very strange, much like an equirectangular image does. Finally, we are going to allow you to teleport in a sense by flipping quickly through multiple images inside VR. We are even going to use a 360 degrees still video of images, and also fly. Yes, fly like a superhero. My friend and I attached my 360 degrees camera to his drone and flew it around outside his house as an experiment. I'll share that immersive experience with you. So let's get started, we've a lot to cover in this chapter. 43. Painting the sphere. In our first piece of code, we are starting out simple again. As you see from line 23, we are loading an IMG asset and giving it the ID orb1. That image is a 360 degrees equirectangular image taken with my camera on the rocky beach with a tripod. You can see San Francisco's Golden Gate Bridge in the distance. This image is painted on the inside of the sky sphere on line 28. That's it, simple and effective as an immersive experience inside a VR headset. Try it out with a VR headset. A more realistic experience than our previous examples. Chapter 4 can be found on GitHub here. At Rocket Virtual https://rocketvirtual.com/360vrsphere. HTML https://rocketvirtual.com/ .44 Problems with this photo. Now I'd like to point out a few problems with this photo for learning purposes. First, it's a still single photo, so there is no moment of the ocean waves. It has no seashore sound, and if you look downward directly toward where your feet would be, you will see part of the tripod where the camera joined the image, and the shadow of the tripod itself. Also in the distance offshore there is a rock formation which wasn't joined correctly at one of the edges as the image is wrapped around. Finally, I'm in the image. That's not a problem, but maybe you want to be alone on the beach to relax, without looking at me in all my photogenic stillness. You can edit your photos with a photo editor, such as Photoshop or GIMP, but you may find that hard because of the equirectangular aspect of the image. No worries if you are not skilled in photo editing, but I'm going to try anyway. All assets are provided for you in the examples. I was able to remove myself, and the tripod and its shadow from the image. However, photo editing a equirectangular image with complex natural graphics, in this case sand and rocks, is difficult. You'll want to edit your 360 degrees photos as little as possible, or not at all. At Rocket Virtual https://rocketvirtual.com/360vrsphere2. .html https://rocketvirtual.com/360vrsphere2.html. In glitch 360 vrsphere2.html and in browser here. 45. So now let's add the ocean wave sounds and fix the final joining at our feet where the tripod used to be with a sand-textured circular plane. It is not perfect, but much better overall. At Rocket Virtual https://rocketvirtual.com/360vrsphere3. .html https://rocketvirtual.com/rocketvirtual.com/360vrsphere3. In glitch 360 vrsphere3.html and in browser here. Now let's take a look at the code. The code we added should be recognizable from our earlier chapters. The camera rig on line 73, with left and right hands on lines 77 and 79. The Ocean audio on line 55. With JavaScript code attached to our Play Ocean button on line 84, with audio handler. The difference being our movement controls don't seem to let us move around. That's because we haven't included a frame extras like we did in previous examples. Our position is fixed from where the picture was originally taken. Sure, we can look around by turning around, or maybe swivel around in an office chair. What if we could teleport to another VR scene, to many scenes in the same web page? 46. Teleporting through multiple 360-degree scenes. This immersive experience in a VR headset should be near realistic, with multiple VR scenes. The next example code is very large, 485 lines. The examples also uses large graphic files and still images in a streaming video. I have manipulated many of the graphic assets in Photoshop and in a video editor for 360 degrees images myself. All this will allow us to teleport to locations I have photographed in 360. I have not blurred out any of the faces, as I have asked and acquired the rights to the images. All others have been photographed in public accessible spaces. I will be in many of them, and I give myself the rights to myself. With all the graphic assets used, this page may take up to 30 seconds or more to load. Please be patient. On GitHub here. On Rocket Virtual at https://rocketvirtual.com/360. vrteleport.html https://rocketvirtual.com/. In order to keep this book reasonably succinct, and to not bore you, I'm going to refer to articles I have already written on the internet explaining much of the code provided here with a few small changes to line numbers, and such. https Moments free open source code 295E4F9FBDF047. Screenshots from flying drone with 360 degrees camera. On Rocket Virtual at https://rocketvirtual.com/360. vrteleport https://rocketvirtual.com/360 vrteleport2.html. As promised, the next example uses a 360 degrees drone video I recorded while a friend is flying over his house. You may experience dizziness due to the fact that your perspective is flying and shaky because of the wind on that day, and the heavier weight on the drone from the attached camera. Also, I didn't edit out the drone noises, which makes it sound like a bunch of angry bees. Besides the drone above you and its shadow on the ground, you may notice some choppy delays in the streaming of the video from my server. The reason for this is the video is true 360 degrees footage, and a very large file is coming across the internet. If your download speed, or number of hops, from the server is many, or even if your internet access speed is constrained from many others using your cable internet at busy times of the day, you will experience stops and starts in the video. 360 degrees video is inherently much larger than regular 2D video. The reason for this is because it includes much more data for views all around you. Imagine a cube face, one side is 2D video, height and width, whatever the resolution. Now imagine that all the 6 sides of the cube, while not an exact and perfect analogy, you see there is much more data to download. Of course there are compression algorithms involved, but suffice it to say, there is a lot of data streaming over the internet. It still all has to be there if you decide to rotate your head around inside the VR headset. 48. Solving the large 360 degrees video file problem. On Rocket Virtual at https://rocketvirtual.com/360, VR Teleport https://rocketvirtual.com/360 VR Teleport 3.html. One solution to the large file download problem is not to use 360 degrees video at all, but a limited stream of 360 degrees still images instead. This is demonstrated in a previous example, and again here with many more still images. Yes, it's not a perfect solution to the choppy start and stop video, but it's one compromised solution. A better solution would be to move the data from the server closer to the VR headset by placing it on, say, a LAN, local area network, or home server. Then the limitation is usually just Wi-Fi access speeds, but if you have a tethered headset with a graphic card inside the server itself, serving up the graphic video files as local host, that would be the fastest yet. However, that is not a normal standard setup. Perhaps in the future there will be ways that a server can only stream the image data that is necessary to the VR headset, and respond dynamically with two-way communication over the internet when the user begins to rotate their head, and then provide extra data at that time only. However, there still might be some latency issues in response time over greater internet distances. The final way would be to package everything up into an app and pre-download it at install time. 49. Hosting 360 degrees video on YouTube. Another way to host and view 360 degrees video is by uploading it, in a quadrectangular format, to YouTube, then viewing that with a link in the VR headset. The best way to input that link and select it is to already have it typed into a previously created web page with a shorter URL, and bookmark that page in your VR browser. Here is one I recorded in a 360 degrees video and uploaded to YouTube of me playing a pinball machine at my favorite old-time pinball arcade. I sometimes get a little excited with the game. https://https://https://http 50. Chapter 5, Social VR. Up to this point, we have been alone inside our VR headset. Meaning no one else is present, except maybe in still photo form. Social VR is about having others experience, usually the same VR experience, as you do simultaneously, like having a real person near you in real reality. Meaning multiplayer type experiences in VR with representative avatars, and with audio talking, etc. Before we get into how to do this ourselves with actual code, let's first examine some of the current VR social platforms that exist at the time of this writing. In no particular order, one of them is Mozilla Hubs. 51. Mozilla Hubs is by the same people who bring you the Firefox browser. 52. Another one is Frame VR. Another one is VRland.io. 53. Facebook Meta has created one called Horizon Worlds. I'm not going to recommend any specific social VR platform over the other because this book is partly about creating a shared VR social space of our own, with code. Still, there are lots of options out there already, and I believe there can only be more to choose from in the future. If you choose to build upon those platforms, that's fine. However, remember one thing, even if they have free hosting options initially, you still have to play by their rules, and with their tools for building out your social VR space. Maybe one other important thing, once you build out on any one specific social VR platform, there is currently no way to transfer your VR content assets to another, except by starting over on that new platform. 54. Networked A-frame, NAF. My social VR spaces, art gallery, private island, VR office. All self-hosted on my own VR server. It's not that well known or tried, but there is an A-frame component called Networked A-frame, or NAF for short, that works with A-frame to give multi-user capabilities. It can be found on GitHub here. I have used earlier versions of it to build out a few VR multi-user spaces, as shown in the image above, and have tested it with up to 5 people simultaneously in VR from separate locations across the internet at the same time. One of them was in England, while I was in California, San Francisco. It works with both VR headsets and browsers too. So you can experience VR with friends or customers who don't have VR headsets yet. I will be completely honest with you, if you're not technically inclined, it's not easy or trivial to set up at all. It usually requires your own hosted VR server configuration, either on the internet, or sometimes it can be hosted from your home, on a cable network. But again, be warned, it's tricky to set up. 55. Your own VR server, and why? Why? I'm tempted to say, just because. Why not host on one of the previously mentioned social VR platforms? The upside is of course that you will have access to a larger VR traffic flow through these platforms than possibly your own. However, some self-hosted VR social spaces make sense, such as privately hosted art galleries, your own custom VR office spaces, maybe a custom-built VR game. It's really up to your imagination when you control your own server. Maybe that's the most important reason, it is for me. I can learn all about how things work behind the scenes, under the hood so to speak. I can tune my own tech, debug it, and admit or ban whomever I want, all with my own VR server storage space for my assets. I can make my own rules, within the legal ones, and those of the hosting service. If you want to set up your own server, what does that entail technically? What is the cost? Before we select a hosting service for our VR server, which is really a web server serving A-frame enabled web pages, along with NAF, we need to understand that we will need to use something called Node.js. Node.js is an open-source, cross-platform, back-end JavaScript runtime environment that runs on the V8 engine, and executes JavaScript code outside a web browser, which was designed to build scalable network applications. A scalable architecture is an architecture that can scale up to meet increased workloads, in this case on the server. Also using Node.js on the backend, server side, in combination with front-end, or browser client-side code, provides for a full-stack coding solution with the JavaScript language. So, because we need Node.js for Network to Frame, we need more than just a normal web hosting service. We need one that allows us to run Node.js. Also, A-Frame requires HTTPS to access its pages in a browser, so we will also need an SSL certificate authorized by a certificate authority. Finally, we need a dedicated IP address assigned to the server, and usually a domain name for our DNS entry. Now that we fully understand our base requirements, we can make an informed decision on choosing a hosting service for our VR server. I personally like VPS, Virtual Private Server, services as opposed to other cloud hosting services like, say, AWS. The reason I like a VPS is because I like more fine-grained control over my server setup, and to load and configure all my own services. Besides, I don't need to be greatly scalable for all my visitors, less than say 25, not in the hundreds. For my purposes, the VPS will scale out just fine with minor configuration. Others will differ in their opinions, some very valid, but ultimately that choice is up to you. You will not have to maintain your own hardware, but now you have the added responsibilities of a server admin, as well as the flexibility, and believe me, you will learn a lot of valuable skills. 56. Now to answer the second question, how much does it cost? Be aware that I am not recommending or endorsing these choices. These are just choices I made, please make your own. How much it costs really all depends on what hosting options you choose, and their configurations. I went with a low monthly paid solution. A VPS with a Linux OS loaded, and 2 CPU cores. For SSL certificate I used the free Let's Encrypt. For domain name, I bought one from Namecheap.com. One other thing you might also want to consider is a hosting facility that is near you physically in the world, unless they are very large, and have geographically dispersed data centers. The cost would be a fixed $12 per month hosting for 2 CPUs on a Linux VPS. That's actually cheaper than my Netflix plan subscription. I also have a Windows server, and that's $20 per month, but much harder to configure with Node.js. See my article here for a server Windows setup with Node.js. Can you host an alternative cloud service for less than $12 per month? I don't know. All prices will usually increase from the time of this writing. 57. WebRTC? So I need to mention a few more things before we go further. WebRTC is a real-time communication open standard that supports video, voice, and generic data to be sent between browsers used to build voice and video communication applications. Basically, this is so powerful that it allows browsers to talk directly to each other over the internet, with or without a server in between them. There are 2 network topologies we can choose from to implement WebRTC on Network to Frame, NAF. They are Remesh network or a star network. You can find out specific details here, but to make it simple, Mesh is from browser to browser with no server in between, and star has a server between browser. That may be oversimplifying it, but there are advantages and disadvantages to both approaches. We are going to use Mesh to keep things simple in our setup. Adapters for network to frame. The reason we mention network topologies is because NAF allows you to choose which one you are going to use by selecting an adapter. These adapters set up the communication channels over WebRTC for NAF. 58. In NAF, these adapters have these capabilities. We are using the ebook adapter, which will allow us audio capabilities for our examples. Video is possible as well, but we won't be using that here at first. There is a default version of ebook adapter configured in the network to frame repository, which we will use. 59. Note, at this point you might be a little confused. Why do we need a server at all if we are going to be talking directly between browsers? The answer to that is, we need a server initially, to at least help find, or discover, and set up the WebRTC communication directly between our browsers, on our mesh network. Think of it as sort of like an intermediary friend introducing you to each other for the first time. Once you have each other's communication details, you can carry on a conversation with each other directly. Okay, so now we have a basic understanding of how we will use Node.js on our server with NAF and WebRTC to communicate in VR with each other's browser. Sounds simple when you say it like that, but now we have to set up our server. Best to glance over and begin reading the NAF documentation first. 60. My disclaimer. I, the book author, of course cannot be responsible if your specific server setup doesn't work out for you, for whatever reason. You must take full responsibility for all your decisions and actions going forward. I have done my best to explain things. If you feel it is too complex a task for your current skill level to achieve successfully, then don't do it. That's completely fine, we are all learning together, best to skip ahead to the next chapter. Some assumptions. Some assumptions about my server setup. I have an Ubuntu 20.0 for server version of Linux setup on a VPS as mentioned before. So for my purposes, I am going to use a LAMP stack. This is because I have other things I want to add to this server such as a MariaDB SQL database, PHP, and I'm using an Apache server to serve up my web pages. You don't need the SQL, PHP, and you could use Nginx instead to serve your web pages, or even IIS on a Windows server. More complex to set up with Node.js, but I'm using Apache on Ubuntu. 61. Sudo apt-up, sudo install, sudo now we sudo up u 6 sudo reboot sudo 6 good sudo 6 type 6 l u 6 no o it now we are going to install sudo apt. I have that 7 after under an 7 testing. The node NAF process will run and initialize, assuming no errors. Now, open a browser from a desktop computer, type into the address bar, substituting with your actual domain name. Open two tabs with same URL to test. https://yourdomainname.com 30 https://your 80. Clicking lock on address bar shows, depending on, click 81, in 82. This will show SFT. Now, H. 8. Chapter 6 is some social VR spaces. We are going to start out this chapter by modifying the basic audio.html file located in the Network to Frame Examples folder. This gives us positional audio in VR. It also creates spherical avatars for us, and positions them randomly within an area of radius. It creates a room which we have changed the name of to Basic NAF, on line 47 below. 84. Also notice that we are using the ebook adapter, and audio is set to true. JavaScript lines 13 to 15 are needed and necessary to make Network to Frame, NAF abbreviated, work. We will discuss lines 17 to 36 later on. We added some meta tags at the top which we were using in previous examples. You can see the code on GitHub here. A working example can be found here. Be sure to open multiple tabs in the browser to view more than one spherical avatar in the room. 85. You should see something like this image above. The amazing thing about this is that you have a way to communicate verbally with other persons visiting this same web page over the internet inside of VR. This is rudimentary social VR. Modifying our example further, we are going to make it look much more interesting by adding a water fountain, made out of basic geometric shapes, some colorful buildings, and a few trees. Nothing we really haven't shown how to do in previous chapters, but now our understanding of things should begin to nicely come all together. For the water in the fountain, we introduce another component called the frame particle system component. This component stopped working in A-Frame 1.3.0 and other versions for a while, but we now have a fix. I will be including that in a .js folder directly on the server to stabilize the code fix. What it gives us is a nice particle animation and the impression of a water fountain with particle droplets spouting out of it. It's not perfect, but if you play soft audio sounds of a water fountain, the illusion becomes more believable. The more quality sensory input you can add to your virtual simulations, both visual, auditory, tactile, say though haptic feedback, and in the future olfactory, and things like fireplace heat, from a safely. 86. Placed external heater, cold, wind blowing, variable speed fan, etc., basically makes the simulation more believable. You can find the modified basic NAF3.html on GitHub here. See it in a browser here. Click on the spherical ball on top of the tall cylinder inside the fountain to activate the water audio. 87. Hexoplex Garden. You can use this scene to put a few custom 3D models in the buildings for viewing. https://funbit64.art 30 https://funbit64.art 3025 hexoplex.naf.html social VR. Hexoplex.naf.html at main times Mike McAnally social VR, github.com. We are going to change the spherical avatars to custom avatar heads in the social VR scene. Keep going. Avatars. Having customizable avatars, rather than generic spheres, or robot heads just seems like a given for any social VR platform. 88. https://mozilla.github.io/hackweek-avatar-maker https://mozilla.github.io/hackweek-avatar-maker. Now we are Going to attach some avatars made with the avatar generator link above to a few new social VR scenes. So have some fun making a few new avatars, and then export them. You'll see that they create a custom_avatar.glb file. We are going to edit that files inside of Blender. So first install Blender on your computer if you don't have it already. Then open it, select away the splash logo, then delete the cube with the delete key. Now import our custom_avatar.glb file. Editing 3D object models with Blender can be a little difficult. You may need some basic instructions on how to use and get around in Blender. You can find that information here. 89. Select and remove both hands, we are not going to use them from this model. 90. You do that by first selecting the model and then selecting the edit mode with the mesh displayed, as in the image above. Then change your view perspective of the avatar 3D model so you are able to select and drag on the hand only. Press the delete key on the keyboard. Then delete the vertices, edges, and faces repeatedly until they are all gone. Keep going till all you have left is some skeleton-like objects. Don't worry about these, leave them alone for now. Rotate the perspective and delete the other hand the same way. 91. Now physically rotate the model 180 degrees so its back is facing towards you. Then export the 3D model with these settings. No animation checkbox. 92. Deselect the animation checkbox. This will remove the animations, but also reduce the overall size of the model, causing it to load much quicker. 93. Here is what you get when you apply the same modified avatar to robot head in our previous Hexoplex scene. Remember to change the scale equals 111 on the head template as well to increase avatar model size. See the code snippet below as an example. 94. So it might seem like our avatars are working out fine when not wearing our VR headset, but once we compare between desktop browser and VR headset, you will notice that is not the case. 95. Our avatar body is a whole head and torso attached, and when we move our head forward and backward inside the VR headset, the whole torso body moves along with the head. This of course doesn't look natural at all, so now we will need to separate the head, basically amputate it from the torso inside of Blender and save both parts separately. Then to fix this problem, we will need to add the head and torso separately back into our avatar template. Yes, creating avatars is much more work than you would think. 96. Head-only avatars. Code examples of the Hexoplex garden with an attached avatar head can be found here on GitHub. You can attach a selection of different pre-configured avatar heads to other HTML files, which will reference the same social VR room space in NAF, making them all appear in the same space. This will give variation of avatars in the space, and allow for individualization. Coding up an extension to the Mozilla Avatar Editor, which automatically inserts the desired custom avatars into a room, is beyond the scope of examples in this book, but can certainly be achieved. You also might want to have a login system set up to the server, hence the extra database and PHP installed earlier in Chapter 5, and many other additional features for visitors to your social VR space. In browser, 97. Art Room Gallery. If you are an artist and wish to share and sell your work over the internet, but don't have a physical art gallery to show your artwork in, not a problem. Make a virtual reality art gallery. I did. Of course, you will be limited to those who visit your web page, and maybe those that have VR headsets alone, but traffic can only increase over time, as more and more people enter VR to view, buy, and collect art. You can see an example of a generic art room gallery on GitHub here using open-sourced art from the US National Gallery of Art. In browser https://funbit64 https://funbit64.com 3025 artroomgallerinaf.html 98. Sci-fi themed island. My VR history. More than a decade and a half ago, I created a themed science fiction virtual space on the then very popular virtual world social VR platform called Second Life. Later I moved it to another open source 99 platform on OS Grid using OpenSimulator, and then once again to my own server setup using Diva distro called Viradu. Now finally, after all this time, I give you a themed Great Science Authors Island VR social club meeting space that doesn't need a special viewer download installed, just a WebXR enabled browser, which works with most VR headset hardware, and all the source code can be found on GitHub for free here. You could also retheme that space as a VR office complex on a private island, club meeting space, shopping mall, etc. Currently you can pass through walls on all of these examples, but we will resolve that in our next chapter. In browser https:// other avatar systems. There are other avatar systems besides the one we used in the examples. They are more extensive, with rules and possibly fees. The links below should be of help in further researching. https://readyplayer.me https://readyplayer.me/ready-player-me/integration-guides/web https://avatarsdk.com http personalized avatars. This is a GLTF file version of my custom avatar. Another avatar type would be a customized avatar from a personal face scan. Mine was actually from an MRI machine, but that's another story. I then processed my medical data through mesh editing software to simplify the number of vertices, and to reduce the overall file size. I replaced my hair because the MRI scan didn't resolve it properly. Also in my case, some added texture painting to give skin tone and hair color, which I haven't done just yet. There are also my closed eyelids, which need to be modified, and eyeballs put in. I chose not to go any further with my own custom avatar. Building your own custom avatar can really be some work. Fortunately, in most VR use cases you won't need this level of realism, because most people will accept a cartoon-like avatar. That may change in the near future as more avatar uses come into play, specifically with, say, business VR applications where you might actually meet the person in real reality later. There is also the possibility of face tracking. Here is a link for more current information on starting to building your own custom avatar. https://vrscout.com/news/create-your-own-VR-avatar-for-the-web-based-metaverse 101. Video avatars. Screenshot of me as a video avatar using an earlier version of Network to Frame. Desktop browser-based applications for video conference meetings are useful and very popular when everyone can't be in the same physical space. If you don't require everyone to have a VR headset to participate, one of the things the ebook adapter for NAF can do is video streaming. You can use a video conferencing camera stream displayed on a cube or other object surface to substitute as an avatar. 102. Although bandwidth limitations will quickly slow down over an internet connection using a mesh network topology, simply because all participants in the browser VR are streaming video to each other simultaneously. The more people video streaming in the same VR space, the more congested the network connection will become. This is usually not a problem if you have a few people participating over the internet, or more rarely even if you are using a fast Mbps LAN. However, by changing network topologies, this problem can be mitigated. Switch to a star network topology and a dedicated media server to support this. Using the Janus adapter is a good solution for this. Here is a code example snippet I used to video stream with the ebook adapter. My example is not a perfect solution and could use some more work, but it demonstrates the possibilities. The key things to notice are that video is set to true on line 139, and that networked video source is added to the A box on line 162. 103. Gifting 3D printable assets. 3D printed island topographical model gift. Most of our 3D models are finally converted to the GLTF format for loading into VR scenes, but they can also be stored in other formats, such as STL. Above you will see a picture of a 3D printed model of the island used in a previous example. It makes sense to gift the downloadable model to someone who has a 3D printer as well as a VR headset. Why? Because it makes the virtual reality experience have a real-world footprint or presence. Something that is free and physically real, that can be used to advertise and show your VR scene to others. Something that you can actually touch, feel, and talk about in the real world. 104. Chapter 7, Bringing It All Together. In this final chapter we are going to bring it all together with some of our previous examples, but it will be more complex, possibly a challenge for some of you, because frankly, it was for me too. We will be using simple navmesh taken from an open source example here on GitHub. Thank you to Ada for this excellent example. Try climbing the ladder with your controllers, so cool. I think Mario. https://github.com/adaroscannon/a frame-xr-boilerplate. https://github.com/adaroscannon/a frame-xr-boilerplate. 105. This XR example is very complex and can be used even as a template for AR, hand tracking, and physics. However, since we only need the simple navmesh constraint part, We will put that together with our Hexoplex garden example, in which the walls created by the use of a nav mesh can be passed through on a browser desktop or laptop, but not inside the VR headset itself, in which it will be constrained by the GLTF file. I also added in the teleport blink code originally taken from here. https://github.com/a/frame-blink-controls. Although social VR is enabled with this network to frame example link below, you could add network frame to the boilerplate XR example above as well. Through on a browser desktop or laptop, but not inside the VR headset itself. Going up the ramp to the roofs of the complex, something again you won't be able to do without a VR headset. Sorry, I just couldn't get that part to work effectively to my satisfaction, along with the teleport, and without a toggle panel selection, used on the left controller in the XR example, which I thought was a bit too cumbersome myself, to quick and easy navigation, so I just didn't include it in the example. Although social VR is enabled with this network to frame example link below, you could add network frame to the boilerplate XR example above as well. https://funbit64.com 3025 gardenxr.html. https://funbit64.com 3025 gardenxr.html 106. I also added links to other projects using code snippet inside one of the Hex buildings, as well as video I shot with my phone at a maker fair here in the California Bay Area a number of years back. Now the link below explains how I built the GLTF file for the nav mesh. https://github.com/a-frame-inspector-plugin-recast. https://github.com/a-frame-inspector-plugin-recast. To do that I had to strip almost everything out of my https://funbit64.com https://github.com/a-frame-inspector-plugin-recast. https://github.com/a-frame-inspector-plugin-recast. To do that I had to strip almost everything out of my Hexoplex HTML example, after adding in the recast JavaScript plugin and putting the component on the uScene inspector plugin recast, then enter the A-frame inspector. Here is a link to what I had to do to build the nav mesh and export it. https://funbit64.com 3025 gardenxrnavmesh.html. https://funbit64.com 3025 gardenxrnavmesh.html. https://mike-macanally/mike-main/gardenxrnavmesh.html. https://github.com/mike-macanally/socialvr/blob/main/gardenxrnavmesh.html. https://github.com/mike-McAnally/social-VR until it works. Until it works. Works. I had problems with my meeting. https://github to walk through. If you have problems, try removing ht 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 https https:// to walk through. If you have https://funbit60 funbit https://github.com/mike-McAnally/social-VR/blob/main/gardenxrnavmesh.html https://github.com/mike-McAnally/blob/main/gardenxrnavmesh.html You will need to strip everything related to network to frame, only the things you don't want persons to walk through. If you have problems, try removing things and changing the parameters of the build 107 until it works. I had problems with my meeting table, so I removed it. If I really wanted to stop people from walking through it, I would have to replace it with a simpler entity like a larger cylinder which takes up the same space as the table. Most likely the resulting nav mesh would then allow people to teleport on top of the tabletop. Ultimately, if you need to edit the nav mesh export, you should be able to do that in Blender. I can think of ways you can create secret doorways and passages into mountain caves and other things with my island example. NavMesh allows for some creativity as shown in the ramps to the rooftops of the hex buildings in this example. Here is the HTML code. https://github.com/mike-McAnally/social-VR/blob/main/gardenxr.html https://github.com/mike-McAnally/social-VR/blob/main/gardenxr.html Treasure Island Art Gallery. Treasure Island Art Gallery is another example. There is the lagoon, with a submerged treasure chest which is full of simulated gold. 108. Check it out here, https://funbit64.com 3025, tisland.html https://funbit64.com 3025, tisland.html Source on GitHub, https github.com McAnally WebXR MISC blob main tisland html https github.com Mac Source of NavMesh generator HTML. Notice the parameters used above in the image https://github.com/mike-McAnally/WebXR-MISC https://gitlab.com/zack-geek/a frame-en6 ropax https://gitlab.com/zack-geek/aframe-en6 Ropax VR launch pages. At some point you may need to have launch pages for your WebXR examples. Jumping from page to page inside a VR headset is less than optimal because of the wait times for loading of assets. Providing a launch page mitigates the user experience somewhat. Because we have installed a LAMP stack earlier, Drupal is an excellent solution to allow you to customize a VR web server and content management system. With many features and a stable, mature platform, Drupal you can control logins and create content quickly, gluing together your work, as I have done in the Funbit 64 examples. Here is a template you can also adapt for the front page. https://github.com/mike-McAnally/server menu. Inside VR screenshots of final examples. Examples 111, 112, 113, 114, 115, 116, 117, 118, 119, 120. Addendum, optional. Installing Drupal 9. https://linuxhostsupport.com/blog/how-to-install Drupal-9-cms-on-ubuntu-20-04